We will quickly move on to the panel discussion. And then if anybody has any questions, you can put in the chat box and we'll be happy to pick it up at the end of the session. Thank you. So I hope, Mr. Shabir, my first question to you. Yeah. Okay, before that, and I encourage all the speakers to add in their points, although it might be pointed to only one person. So, okay, so when we speak about precast, logistical feasibility, supply chain availability, and limited space on construction sites are some of the critical challenges. So, do you think how these challenges are being addressed effectively currently? And if so, how are they being addressed?
All right. So I think the question is in regards to the availability of space, right, at the site?
It is regards to the availability of space and then the transportation, because the large chunks have to be transported. So how to manage all these things, because India's infrastructure is it's not planned for all these things. The given the way currently the cities are built.
Right. So see, I would also like to highlight that all the technologies are not meant for every project, you know. So there is a definitely target market segment for every technology, and you have to look at the viability, adaptability of technologies in each of these projects. But when it comes to precast projects, certainly we first do the feasibility. We understand, if our trailers could potentially reach the desired sites from the factories. A lot of trial runs are being carried out. The space is available around the site for storage of the elements prior to erection and things like that. In case of large scale projects, sometimes there is a site based factory wherein it caters the needs to the subject project. So definitely these potential challenges are addressed, and now the road network is improving day by day in our country's context, and there is no as such problem in order to potentially you know like transfer the elements from one location to another location. Definitely cost is one such impact we need to study for a given project. But then as we speak in today's era, more than 90 plus factories are there across India who actually fabricate structural components like precast beams, columns, shear walls, staircase, landing, mid landing. So and the factories are increasing every year on year. So we have got sufficient ecosystem in the country to construct precast buildings across state wise. But yes, as you rightly mentioned, that these challenges are definitely studied for each and every project prior to the start of the project. Yeah.
Okay. Anybody else wants to add on this?
So I think I will completely agree with Shabir what he said, that Indian road infrastructure and with GST implementation, I think things have pretty much eased out. So we don't anymore have the waiting period at the borders, city borders. So I think something that used to take maybe 10 days is taking now 4.5 days. So logistics used to be a big challenge. In fact, a lot of customers do ask us as to how you would be able to transport a building which is 5,000 tons and 10,000 tons containing so many trailers. So just to give you an example as to how logistics work like a magic in India now, of course there is no end to how much we can improve as a country and as infrastructure. So we are doing a very large tire factory for a company called BKT. Balakrishna Tire is a very known name. We see it all the time. They sponsor IPL and they are a very big name. They are in Bhuj, and Bhuj is not, something that's in the middle of a main city or something. We were given out an order of 30,000 metric tons to construct a plant which single building is 300,000 square meters, and it was all to be done in 1 year. Now, this involved sending 2,000 trailers at site from all parts of the country, particularly Chennai, as well as north of India, from Uttarakhand. Anything, 1,500 kilometers. Except for one trailer out of 2,000, that also not because of the road, but the vehicle broke down, everything did reach in an average time of 4.5 days. Now, that's what I think our infrastructure and also availability of good quality vehicles in India has done to the entire logistics. Because all this precast and prefab off-site construction is very, very much dependent on the kind of logistics and the road infrastructure and the borderless, country that we are building. So these are my inputs on, the logistics. Yes, there is always a headroom to make it even better and, have more trained drivers, have better vehicles, have better tracking mechanism. And there is no reason why can't we reduce this 4.5 days, which is today, which we are very happy about, because earlier it used to be 10, 12 days to maybe 1.5 days. And it is possible. It is possible. And that can be a real, game changer going forward. Thank you.
Thank you, sir, for your lovely insights. So my next question is to you only. So we speak about PEB systems and offsite construction, like you mentioned. So that demands a lot of quality and precision. So how are technologies influencing the precision, efficiency, customization, and quality of the output of PEB systems?
Yeah. So thank you very much for the question. There are two aspects. One is there is a lot of quality that translates into the final quality, which is quality of design and detailing. As we say that the more time you spend in design and detailing accurately and deployment of tech during the design and detailing, because ultimately in a customized environment like ours, every single building is different. It is all customized. It is all tailor-made. So we deploy tools in the first stage, which is design, engineering, and detailing, which automate the whole process in a 3D formation. So the design is 3D, and the detailing, which used to be mainly 2D, is now 3D using Tekla, using Xsteel, using StruCAD, and using the other Revit, which is 3D, which gives you complete real-time visibility of what's happening, what is the interaction between various members. And then you break it down into like a Meccano set, in various parts, and then you number the parts. So I should say that use of these very advanced softwares with a lot of in-house developed plugins make sure that each component is designed and detailed very well so that it fits on the site. Second part of it, so precision engineering, comes through this tech. And of course, a very, I should say, trained manpower in the particular segment. So we have 5 engineering offices, spread across the country. So softwares also can be used by people, who are trained to use them. And then comes what sort of automation you have in your off-site factories, right from cutting the steel to finally painting it. So we deploy a lot of tech in terms of automating the uses of steel with minimum wastage to automated welding. There is no human element that comes in there. So welding is super critical in any pre-engineered steel building per se, because everything is customized. So there's a lot of welding that happens. So the machines which are deployed these days have automated control systems for heat and current and deposit and entire running lengths and everything. And then whatever manual intervention is also there, this has to be done by highly qualified welders. In fact, we equate in our industry, not us only, we equate the welder equivalent to a pilot, because like a pilot cannot fly all kind of planes. They have a type rating that if somebody is flying A320, unless they are type rated to A380 or a ATR, they cannot fly. They can only fly a plane that they are trained on, not that a pilot can fly all kinds of plane. So similarly, in factories of ours, a welder, there are, let's say, 6 type of weld or 7 types as well. Each welder is pre-qualified for a certain type of weld, maybe 2, maybe 1. Then that welder can only do that kind of a welding only. If he has to ever do some other kind, so it's a very high precision. And then of course the quality testing through DP and radiography and ultrasonic testing. So I think since everything happens in the factory, all the precision has to be in the engineering and at the factory level itself. The site can only check the line and level. They can't correct anything. If you have not detailed a thing properly, factory cannot do anything. And if you have not manufactured a thing as per drawings, site cannot do anything. So I think it's a chain, of the entire process that has to work seamlessly. So I think this is how we handle the challenge of precision engineering as well as fabrication, so that whatever is on the drawing board is get physically erected at site.
Thank you, sir. Anybody else would like to add any insights from Shabir, architect Vinod, or Dr. Rami? So my next question is to architect Vinod. So I think you briefly touched upon, so you spoke about architectural flexibility or our modular systems, or architects are they losing their identity and all of that. So, and you also said it is no. So I would like to know how are, advancements in design tools, materials, and facade systems, how are they, helping architects to expand their possibilities in case of modular buildings?
Yeah, thank you. So, I think, there's been a lot of change in the industry, a lot of, materials coming in, a lot of technologies coming in, first is in terms of the construction technology and, and the construction materials, So that's the first thing, So, earlier I remember we used to still look at, a pre-engineered buildings as a hybrid sort of a system, as in it could be, semi conventional versus a semi-modular. We used to look at it. But now the way things have evolved, there are a lot of materials in the market, and as I touched upon before, that like for example, we don't need to do a brick wall if you're doing a pre-engineered building now, correct? Because there's been a lot of advancement now in terms of materials, As in there are a lot of drywall systems which are light, which you can get the right insulation systems, can control the weather, whatever, correct. So there's so many things which are happening there, correct. So there's definitely a lot of technology which has come in the market, correct, which helps us, correct. Of course, the challenges what I mentioned, they're separate challenges, design as a challenge, which is always going to be there, Okay, but also I think the panel co-panelists also talked about is how the detailing matters, how engineering detailing matters, But again, once you start moving into more architecture buildings, where let's say commercial buildings, where the architecture expression, as in the facade system, might be very important. Now that would actually start from the architect's office, as in that there will be some level of detailing which will be done using BIM or softwares which are necessarily required in that process, and then that gets transferred to somebody, the vendors who are working on the project, correct, and that detailing is further carried on, correct. So basically now what happens is the transition between one office to another office, which means that there has to be a seamless integration in terms of the software integration of the project, so that it can be taken by the next agency and carried forward, correct. So there's a lot of collaboration which is required, correct. Also, one thing I would also like to touch upon is slightly aside from the question you asked was also that once buildings become more engineering, correct, and this is where we also suffer a lot, is that we need to get into a culture of shop drawings. Correct. And unfortunately, in this country, soft drinks are not looked upon very seriously. Correct. Because ultimately, they are what matter. Because those are the drawings. Ultimately, a thing is built. Architects can put in the concepts, ideas, but ultimately, it comes to a lot of technicalities. So there's a lot of support which is required to the architects once you start getting more complex buildings in terms of the shop drawing. So again, this is something else, but yes, I think there's enough technologies now in terms of softwares, enough construction systems, materials. So I think everything's possible largely.
Site conditions, when we talk about specific infrastructure projects, see, site conditions affects the efficiency of the system in the sense that if we are, if the site is not quite favorable, then making it favorable requires certain costs. But overall, the success of precast is not very heavily dependent on the site, except under few conditions where the accessibility becomes the problem. Just for an example, one of the projects, one of the requirements that we got was construction of precast toilet blocks in Mumbai, that too in very, in the slum areas where the approach was any machinery reaching that location was difficult. Even a group of laborers reaching there was a challenge. So in such a situation, getting precast done becomes challenging. But apart from such specific situations, wherever a cast in situ can be done, 80% of the time it can definitely be done in precasting. And especially with the type of technology and the type of mold support we are getting today. So I don't think there's a major gap there.
Okay, thank you for your insights. So one question that I want to ask everyone is, so we speak about primarily modular systems. So do you think, looking ahead, will India's cities adopt fully modular construction systems, or will the future lie in hybrid models combining precast, prefab, and conventional construction methodologies? Anybody can start.
As per my opinion, it has to be a combined system. It can never be one thing fits all. Like just like Shabir had mentioned previously, that every technology has got its own applications. It cannot fit every other application. That's my opinion.
Okay, I would like to have everybody else's opinions.
Well, I think I tend to agree with Dr. Amin that it will it will be number one, the modularity itself in India will take some time because the way we are structured and the way we are wired as Indians, to think our own way, and modularity is still very, very low in India. Everybody wants things their own way. So one is that we will have to start thinking modular, and that is when things like precast and prefab and these things do deliver much more advantage compared to when they have to be customized. That's point number one. Point number two is they will all go simultaneously. In a single project, all three or four technologies can be used. So if I was to give you an example of, let us say you are developing a logistics center, right? So there the roads will be precast. Roads can't be anything else. The pavements and the other, boundary walls and stormwater drains and everything can be precast and will be and should be precast. The concrete tilt-up walls and other things, including foundations, can be precast. The columns could be precast or steel. The flooring can be concrete, and the entire rafter system and the roofing cladding can be steel. So it'll be a combination of what is the best use case for a particular product. Now, I don't think anybody will try and force fit a particular solution just because they make it. So I'm sure when when Mr. Shabir, markets his products and solutions, or when architect Vinod tries to use it, and doctor also looks at the infra thing, we don't try to force fit a solution. We rather see what is the best fit for this particular project and this particular application. And many times we marry two or three solutions together to give the best, like you said, concrete and this. So I think everything will have to work in harmony for delivering the best results for the intended use. This will be my view on this. Happy to hear others' views on this. Thank you.
Yeah, thank you, Manish. So I just like to add there, So of course I agree with you that there's a market, there's a wide market, there are different industries. So not every solution will fit in every industry, correct. And so I think the market is will remain fragmented, and technologies will be applied to the right the domain where it is required, But also I feel that but one thing we are always looking at, everybody's looking at, at the end of the day, whether it's the clients, we are looking at flexibility, right? We are looking at, creating things which are flexible. I should be able to create a system, without, as a designer, I don't want to get bogged down with, the steel size, correct, or the concrete size. I would like to create something which is like, whatever I feel, correct. Yes, right. So now looking at that, there will be like, other technologies which are going to come in the future. One is definitely robotics, correct. And so that is also going to come, correct. And there is also, I think, 3D printing is also going to come slowly, and it's going to increase a lot. And, the way I look at it is, 3D printing is something which allows you a lot of flexibility. And of course, it might take some time to come, but, you could do any shapes, sizes, whatever, correct. But yes, the bottom line still remains the same. I think it will be project specific. Some projects need flexibility, some projects don't need. Like when you're designing, let's say, an industrial building, you don't need that flexibility what you would require in, let's say, a museum building, right? Correct. So it changes. A hospital need not be as flexible as something else, a commercial building. Commercial buildings need to be very flexible. Correct. So I think it's going to be very project specific, the domain specific. And also, I think we're going to see a lot of upcoming technologies, which will also, in some cases add to the current technologies, and in some cases they might, replace some, existing technologies as well.
Thank you for your insights. Shabir, you want to add anything to this?
Yes, I think all the delegates, have told very right that single technology cannot be used for any given project. It's always like marrying of whatever suits for a particular project. For instance, in precast also, foundations for high-rise buildings are never meant or cannot be done in precast. So it's always done in conventional cast in situ, and then we take up the buildings above. For a merely a very high-rise buildings, we have also evaluated that up to a certain story, we do it in precast, that is in concrete precast, and then thereby we have done it in steel also, the remaining last few stories, to reduce the tonnage of the elements or the dead weight of the structure, and likewise. So it's always like amalgamation of various like technologies or methodologies of construction available for a given project, because ultimately see it all boils down to the commercial and costing also. So whatever technology finally reduces time, saves cost, and delivers the exact right intent what architect's vision is finally adopted. So yeah, I agree with everyone.
Yeah, thank you for your insights. So, my question to Manish now. So, when we speak about transportation, I think transportation was one aspect that all of you had touched upon. So, are we trying to, the emissions that come out from the transportation? We speak about sustainability, but are those emissions, are they, overriding the sustainability aspect? That's one thing I wanted to ask. One more question was, uh, what do you think? Because apart from speed, quality, and of on-site disturbance and all of that, apart from these factors, what do you think are the drivers for adopting modular construction in India? Yes.
Okay. So before I come to sustainability when you are transporting goods, and generally, uh, uh, touching upon on what is really advantageous in terms of sustainability part on the modular and precast, I wanted to just come in and add to what Sabir sir just said. Actually, Sabir sir, we did use precast foundations in one of the very large logistics project for Indospace in Delhi NCR, wherein all the tilt-up walls and all the foundations, including anchor bolts, were precast, including the plinth beams.
Right,
So
sir. Right.
they only dig the ground there for putting in the precast ones. So I think it is slowly catching up, but yes, it has to be then done not very far away from the site. It will have to be in the proximity, 50 kilometers, maybe 100, not even
Yeah,
that, I
yeah.
should
True.
say.
Correct. Yeah.
So it becomes otherwise a very big mass, but it was very advantageous because otherwise in situ was always a problem. So just I wanted to give you one update because we were the pre-engineered building people and we felt that things did come up very fast in precast. So I think some little bit work is being done on the precast foundations also, not though fully, but I think people have started it slowly. So just wanted to add on, just because this is our personal experience at one of the very large sites. It was for logos in Delhi NCR. Now coming to Anupama, your point on logistics and emissions and all of it. Now, what is happening is that the kind of capacity we need in India, the per kilometer travel for things to reach the final destination determines how much carbon footprint or how much of emissions you have actually spread into the environment. So the large players are having regional centers across India to service the regional markets. India is a very large country, as you know. And if you only have a mother plant, let us say in north of India, and you are supplying everywhere from there, quite obviously you are not helping, particularly transporting things over 2,000 and 3,000 kilometers, and emission being one of the part. So a lot of companies are setting up, including us, and have set up what we call the regional centers, wherein none of the goods have to travel more than 300 to 400 kilometers to reach the final destination. Now that reduces the carbon footprint significantly in terms of sustainability. And in terms of modularity, there is one aspect particularly pertinent to steel buildings, rather, I should say two. One is when you use a steel building, you don't use any significant amount of water. There is neither concrete being casted at site. I'm saying, except for foundations, there is nothing really, foundation and flooring, there is nothing that you are using, everything is steel. And then thereafter, you don't have to cure it as well. So that saves you significant amount of water, which again adds to protection of groundwater table and water in general. So that also helps making it far more sustainable than any other construction product. Then same comes with the formwork, what we loosely called as shuttering. There is no shuttering required above the ground in superstructure when you are using steel or even precast for that matter, right? So there is a lot of sustainability factor that comes in, deforestation to saving of water to, I should say, having regional centers. So these are few things that are making this, and then there is no cleaning up of the site that you need to worry about. And then in the end, when the building life cycle ends, 25 years, 30 years, 50 years, if it is concrete, then there is a humongous amount of waste that you will generate at some point, and what are you going to do with it? If it is a steel building in particular, there is zero wastage, and I'm not talking about that you will make a lot of money and you will recover a lot of value out of steel. Just to tell you, 25 years ago, uh, the steel prices were 50% of what the steel scrap prices are today. So steel scrap price today is about 33, 34 rupees a kilogram. And the steel prices in 2001, exactly 25 years ago, was 21 rupees a kg. So just imagine if somebody used a steel building that time and they are dismantling and they are making a new one. they will actually get 1.5 times of the value of the total steel that they. And then there is no muck that gets created. There is no wastage. It just goes back, gets recycled, and goes back. So I think that way you see how much of future carbon footprint are you going to reduce. So these are some of the factors which I believe. And then of course people at site also. 10,000 people at site, how much of resources they will use as compared to 200 people at site doing the same work. So that also is another aspect of doing things off site in a modular way, in a precast or a pre-engineered, prefabricated way, and irrespective of doing them at site. So these are just my insights on how these kind of technologies can help sustainability in the long run, short run, mid term. Thank
Thank
you.
you, sir. Who else would like to add their points?
Just like to add something here, like just to what Manish is. I think that is a very good insight. I never thought like there's no water being used. Basically a steel building. Because water is a very very big resource. Correct. I'd just like to add to what I think Manishi said. So there's another wastage, so we've been involved with construction projects, interior projects. We see that there's tremendous amount of wastage at sites, and it can go from 5% to 10%, and interiors, the wastage even goes up, sometimes 15%. We waste so much of stuff. Now that indirectly is, helps us, in terms of sustainability. If we can get a zero wastage in terms of a product, that itself makes it sustainable, correct. So that's the first part of it, correct. And I also, one of the other things I remember, this particular client, they came to us and they wanted to design a school building. And they were like, okay, we want to do a steel building, correct. And then we asked them, why do you want to do a steel building? Because very fixated. They said, we have a lease for 10 years, correct. And after 10 years, we need to take the building, we're going to take it back. We might actually shift the building, correct. So I don't know how much that's possible, but I think there's definitely a lot of, there was a thought process behind it, that there's actually a resale value. I think that's the bottom line.
Okay, thank you for that. So my question to Shabir now. So precast or any modular construction demands early coordination between architects, structural engineers, MEP consultants at the design stage. So how are tools and technologies enabling this coordination?
Right. So right now, we have moved far ahead in the industry. Most of our projects, we are doing it on ACC clouds on BIM. We have been ourselves using BIM for precast projects since almost more than 12 to 13 years now. Since a very beginning of the BIM process. Because in a typical given project, I would just like to throw some numbers, like Vinodji also had mentioned about the shop drawings. So let's say for a typical building of 1 lakh square feet apartment or residential buildings, we literally have to extract almost more than about 3,000 number of drawings for every element, whether it's a shear wall, slab, landing, mid landing slab, everything. So it goes without saying that BIM is the only tool wherein you can execute such kind of projects. So as these technologies are widely used by the customers, the reason is to save time and enhance quality. So all the consultants get onboarded on these technologies, and we use BIM, so it makes our life easy. All the clash detections, everything is pre-planned. MEP integration is done in the structures at the very early stage, and that's how the entire seamlessly all the projects are executed. Otherwise, it would not have been possible, without using these tools. Secondly, so it's a very common norm now. The coordination is happening on the cloud platforms, and seamlessly the design integration happens. The planning is done well before ahead of time, so that the project gets completed before time. Adequate amount of ecosystem like resources are available who are well equipped with some basic know-how of BIM. Definitely, we have to train them in an advanced way to deliver up to LOD 500, etc. And then some of the project really demands for using these kind of technologies. Like we did Kuwait International Airport, entirely parametric structure. We had used Rhino, Grasshopper, Dynamo, Revit to come out with the extraction of such kind of designs. Definitely, structural engineering design was one component of it, but then really, making these panels executable or buildable, we had to use these softwares and technologies, and finally come out with the shop drawings. So transforming the complex designs into a 2D format, wherein it goes to the factory environment, then they make the molds, respective molds, and then they make the elements, right? So this is something which is now a global trend, and it's very much usable in practice right now for these kind of industry. And one more thing, like what Manish ji mentioned, definitely, like we have also done a couple of complex steel projects also. So BIM is also widely used in steel structures. Then it goes for laser cutting, bending, and sheet metals also. And laser cutting happens in the tubular sections for cutting of hollow sections, etc. So there also, the BIM model is very much mandatory, and obviously the format accepted by the laser cutting machines, it's step format and things like that. So it also comes out automatically from the BIM model, and that makes their entire life easy. So I think it's a very common trend now, and everyone is using such platforms. Thank you.
Manish, sir, can I have your insights on these? On this?
No, I think I quite agree that there is always a cross usage of various tech platforms to address what Sabir just mentioned. And I think it is also evolving. So there is quite obviously a lot of AI that will come in play sooner or later. Uh, so I think I quite resonate with what Shabir has just said on this subject.
Thank you, sir. One question was on the building codes. Are there any particular building codes that are, governing the construction using modular construction in India?
I think there is a code in the draft. I am not very sure because I am part of the code committee on the what they call prefab systems or something of that sort. But it is addressing more the precast part of it rather than the pre-engineered steel, because for steel there are codes for steel in general usage. I think Shabir will be knowing a little more on if the code is published, but I think it is called prefab systems or precast systems. I think the BIS is working on a code, and it's almost, I think, 2-3 years that this code has been worked upon, and various committees, have had meetings, and I think even the draft was circulated. So I'm not very sure if that has come in the final version of it. It has come out, but I'm sure that there is a lot of work which has been done, and if at all it hasn't come out, it will come out very soon. I think Shabir, is the precast code out as yet or not as yet?
No, so right now this CED 46T12,
Yes,
the draft was released. It's a
correct.
part of NBC, Section 7, SP7, Part 6 and 7. So I think it
Yes.
will be released very shortly. Yeah.
Yeah, so I was a part of the 46, and I think there was some other sectional committees also, and I think it was in very advanced stages and a draft was released.
Yes, yes, yes.
Yeah, thank you.
Okay, thank you for your insights. So one question to everyone now. So be it residential or industrial or any kind of structure for which we are going in for a modular methodology, what do you think, or even large scale infrastructure, what do you think are the challenges as far as India is concerned in adopting these methods? Probably I can start with Dr. Amin first, and then the rest of them can follow.
One of the biggest challenges that I have faced is uh, I'm dealing with government bodies. So the acceptance of new technology, they although it might be an it might be advantageous to the public, but how is it advantageous to the person making the decision? That comes into play. And we have had this discussion with at multiple level, even with Gadkari sir, for having some way that we can encourage government officials to accept new technologies, be it precast buildings, roads, anything. And of course, acceptability takes time. And when it is a government body where their particular KPI are not associated with adoption of new technology, it becomes even bigger challenge. As far as I think one of the point that was raised in between was in India, people are not used to dry walls, and the mentality of people that will take time to grow. But I think it will grow soon. I think that shouldn't take much time. People are growing faster than our systems.
Yes, Manish sir,
Yeah,
would
so
like to add
I
on
think
this.
there are two, three things that I want to add because it's very interesting question. One is uh, right now the adoption of this new tech, be it precast or whatever we're talking, steel buildings or any other new technology in construction, it is always after we have conceptualized a particular building or a structure or a project, right? In the conventional manner. So because we all come from old school thoughts, these are of course relatively new technologies, and I think most of us in our college times, I don't know about others, but at least these were not there when at least I passed my civil engineering, and so may be the case. So therefore these are new. So we are again wired, and generally our structural engineer fraternity or architectural fraternity is wired to think conventional. So most buildings will actually be conceptualized as conventional. And then later on, we will try and fit a new technology of a precast. Or now, of course, the new generation architects and even the old ones, project people have started to conceptualize thinking. Now, look at it. If you have conceptualized a building using in situ concrete, and then you are converting into a precast, quite obviously you will have to force fit a little thing here and there or change the original design, which no architect wants to change unless he conceptualized it. One problem is that, so I think that's a challenge which now is being overcome, because if you conceptualize a building thinking I'm using precast, your architectural forms and everything will be commensurating to that. Second is the way we plan the projects overall. And I'm now talking of clients, because after all, an architect also makes it for a client only. All the time there is an end client. Now, again, we are not as Indians wired to plan very well everything. Where is my window? Where is this? Where is that, stormwater drain going to be? We just say, yaar, somehow let's get started, फिर देखेंगे, we'll let you know. ये तो आप चालू कीजिए, let's. So again, we all will have to start. Your concept adoption can only be as good as your planning. So standardization, conceptualizing, the building into a particular concept or a particular project helps you do it much better, much faster, rather than trying to force fit or maybe change of design. So I would say that everything also should be thought out right in the beginning only, as that where my services are going to be, or in a road project, where my other elements are going to interact, how they are going to interact. So you don't really keep designing and thinking about your requirements as you build. That is how we are wired to think. So these are 3 4 challenges which have to be sort of worked upon. We have overcome quite a bit, but I think there is still a long way to go. And then I should say also thinking standardization. We take a lot of pride in customize everything, and we also take a lot of pride in वो मैंने ऑर्डर देके बनवाया था, it is customized to my requirements. We take a lot of pride in using customized, limited edition kind of a thing, at least for infrastructure building projects and These we will have to get out of the thinking that, it was my, like the Asian Paint ad used to come, Mere Wala Pink. So we'll have to get out of that thinking and, try and say that, yes, take a lot of pride in, I used 100% standard elements in my project, and it still looks architecturally as marvelous as something else. So I think that's, and I conceptualized it thinking of a particular tech and not really started thinking of the construction tech after I conceptualized. So these are, I think, few challenges which will take a little more time to get sorted out.
Shabir, any other inputs from your side based on your experience?
Yeah, actually, Manishji very rightly said this is the same philosophy being adopted and followed in precast projects also. So, in very early days, way back in 2012, we used to convert cast in situ projects to suit precast technology. But nowadays, like people have realized the potential of the technology, and then from the very initial concept design stage, the architects are keeping technology in mind and then preparing the space planning designs, and repeatability and things in mind. And I would like to highlight that, for example, in housing today, you cannot demand, because the housing shortage in India is really, like amplifying year on year, because the housing needs are growing. So any potential customer like middle income group or lower income group, EWG class, they are not demanding that I want such and such interior, or so they are bound to buy a product which is available in the market, right? Because of the available in the market, shortage in the market, and thereby this repeatability and like standardization is definitely happening in the market, and it is very much required to fulfill the gaps between the demand and the supply, but definitely without compromising the architect's vision, ventilation, space planning, and keeping the same quality. So standardization has become now a market need, you know and that's why these technologies are potentially penetrating more and more in the market. And due to also increasing of labor problems, factory controlled buildings or buildings made in the factory are more widely adopted right now, and then the market seems to be growing year on year, in India as well. Yeah.
Thank you, sir, for your insights. So one last question I would like to take, I'd like to have. So one thing is like all of you have been associated with global projects, across different countries. So what do you think are the lessons that we have to learn, or is there anything left to learn from them, or what are your any comparative aspect that you would like to highlight? Anything that's better in India that also we can take. Anybody can start.
So, yeah, one more point I would like to add, that what Dr. Amin mentioned, that there are no KPIs for the government agencies to adopt new technologies. But right now, what I've seen is, let's say, like just before COVID, we had a very deep meeting with UPRNN, which is one of the largest PWD in India. So UP government wanted to, look forward for adopting technology and then do most of their projects in upcoming years using precast, right? So at that point in time, their annual revenue was almost like uh, something like around 9,000 crores. So they wanted to convert most of the projects gradually over the period of time in precast. Very recently, we are doing one one MES project in Army, in armed forces, which is very reluctant to adopt new technology, and because they have very standard norms, everything. So this is the first project which they are doing in precast, a residential accommodation project, which is under construction right now. You will see the inauguration in a couple of months' time, and then they would like to replicate the same precast model across the country. So yes, definitely some transition is happening, but it's taking a bit of time. But because there's a huge demand right now and very less amount of supply happening in terms of quality of products, buildings, meeting the timelines of the project. So there is no other option but to adopt technology, so this is bound to happen. There's no denial of the fact.
So any inputs on the global and Indian comparisons? Like
Yeah,
what
so
are we?
basically, yeah, as you know, these ecosystems are evolving. We're trying to, fine tune our quality, standard operating procedures, the way we are working, the way we are used to work, the mindset. So yeah, it'll take some time, but I think in a decade's time, I've seen the entire industry evolve, and the enhancement of quality process happening, which will eventually furthermore improvise in the next decade. Yes, so but in terms of human resources also, we need to definitely do a very close hand holding with respect to academia, and ensure that the right pool of resources are trained in the right technologies. And then, because right now the industry itself, these potential technologies which are very new in the market, or I would say relatively new, they're not so new also, but then we are also facing shortage of skilled manpower in terms of highly skilled engineers, structural engineers to BIM engineers to the right kind of architects, right kind of contractors with right skill sets in terms of required for project managers, supervisors at all levels. So we need to ensure that right from the academia level, we do this technology awareness, and then people are framed and trained in the right manner, so that they are helpful for developing further ecosystem in our country.
Thank you, sir. Dr. Amin, would you like to add anything?
One of the things which I've observed, I've traveled to Africa a lot, and what I see there is that they are more receptive to Indians. What I see there is a high potential for Indian companies, especially precasters, to go there and have a good market. And the reason why they look at India more than looking at Europe or US, those countries, is because Indians know how to get things done in low cost. And that is very important for them. Getting the right quality, getting the right design at the right price. So somehow I feel that our Indian precast industry can put forth a good standard for not just our own country, but a lot of countries who are more focused on economical growth, and not like more, more of like Manish sir said, everything has doesn't need to be unique. It has to fulfill its purpose first.
Thank you. I hope Manish, sir, and architect Vinod are
Yes,
available.
please.
Yeah, yeah. So any of your
No,
learnings or
not really. Not really. I think it's been very, very, very engaging, and I think your panel, the other panelists, I don't know about myself, but have been fantastic. They're, I think, lot of very deep insights.